Well, hello folks, still got this chest infection business, but we're getting there very slowly. So we'll spend some time doing this DNT, which will be a surplus one we sell on eBay, if we can get it to work. Mark's already looked at it. TX power okay, relay sticking, that's interesting. No receive. Meter lamp duff. I've got 3 of these, and what I don't do is pick the best. I pick the next off the pile and we sort it out. Now I'll have to make a mic up for this, and it differs to the LCL, it differs to the Maxon, it differs to the SMC Oscar, and it differs to realistic, just to make things more fun. And I've got some 5-pin DIN mics which are ready made up, but I don't know what they're for. So you never know, I might have a mic. I won't have, but will I? It'll be something else. So I'll just put that to one side for a moment, which is what the video's about, because they've just been to a radio rally. Mark's here for the weekend, and he and Mr. Chippy have been to a radio rally, Horncastle way. They've brought one of these Selmar 3-amp power supplies. And we've covered one of these before, and notice how the cable's nicely coming out of the cord grip. We're not going to plug this, and we'll do a video on this another day, but I'm intrigued as to which version this is, because the other versions, as it comes, is 1 amp. And there aren't that many sets which are 1 amp current consumption. But there's an awful lot of sets of the time which are 1.5 amp. And what we did on that one is to upgrade the regulator chip from a 1 amp one to a 1.5 amp one. Right. That kind of fits in its little thing. It's just the same, isn't it? You know, there's no way on this earth this can do 3 amps. I can't read that. Right, it's an LM350T. So the bridge rectifier looks probably even 6 amp. It's got a 4700 electrolytic there, which we will change. It's got all the electrolytics would change, and then it's got one of those Mullard mustard capacitors there, which is probably worth more than the whole power supply to the guitar amplifier fraternity. 2200 picofarads, 400 volts. Wow. Somebody must have had those surplus to put those in. So LM350T. So we'll look that up to see what it is capable of, and that will be a forthcoming attraction. They also bought one of those Welsh ones with the dragon on the front. Taran, that's it. Ordinary 3 amp one. I don't think we've ever covered that. We've covered the 5 amp one. What I could do with it is a bit of paper. Are you telling me the floor hasn't got any paper on it? No, Mr. Tango, the floor's not got any paper on it. found some packaging though. There we are. Oh, I was gonna put that over and back, but it didn't work. Right, we'll put that on one side for a forthcoming video. Right, so we've got. I was going to do a DNT, but I took one look at it and didn't feel well enough. So we'll do this baby Midland instead. Plug this one. It's been it's a set that's been acquired over the years or donated, and Mr. Chippy's just gone through it for dry joints because they can be prone to dry joints. It's the Midland 77104D UK, and this is the slightly inferior version. You can tell this version from the 104 UK without the D in it because it doesn't say channel 9 on the channel thing, because this is an up-down rotary encoder. It's not a real channel selector switch. So yeah, and the receivers are not quite as sensitive, but that said, they're not inadequate in any way. So what are these? 1989, that kind of era. So Mr. B, Mr. Mark, has said no transmit, no receive, no audio. So we'll see. That's why I've asked Mr. Chippy to go through it for dry joints. These aren't as particularly prone to dry joints as the 77099 or 77095, but they certainly can do. It's like the newer they get, the worse they get. Don't have dry joints on the Precision series from 1981. I would ask Mr. Chippy not to resolder the speaker, so hopefully we don't have to go underneath unless there is another fault. So it doesn't look like it's been messed with. You know, I can't see any silliness, I can't see any stress capacitors. You notice the reference crystal's glued down to the top of the phase lock loop chip, and it's on long leads. It's to stop shock. Trouble is the chip's going to warm up slightly, isn't it? And it could change the frequency. I think ideally they'd have been better off with a double-sided sticky pad if they wanted to do that, and they afford some insulation as well. Anyway, I'm not the manufacturer. I'm just the service engineer. So if we get this to work, I'll need to change the power lead. There's no point in doing things like that. They always manage not to have a fuse, don't they? So I think it was lighting up, no transmit, no receive, not accept. We've now got a draw of 3 milliamps. I think the standard 5-pin mic is the one labelled Comtron. We'll switch the set on first, and it's lit up, and of course it comes on channel 9, and smoke comes out of it. Okay, that's not good, is it? Pause the video. Okay, so I found, unfortunately, he's introduced a whisker of short circuit. And resistor 608 is what was smoking, which is a half-watt resistor which feeds one of the 8-volt regulators. Now I've got transmit, I've got def receive. I'm not going to bother checking the voltages because that part's being distressed. We're going to change it. I'm going to put a 0.6 watt one in. Got the power. Put the smouldering bat on. Now, I'm not going to edit this out of the video. These things happen. Rarely, but they happen. Do be careful with these printed circuits, they're not as robust as some. Mind you, I think many CB radios are very robust. Try not to damage this getting it out, because I want to see how many ohms it's now reading. Here we are. Let's get the meter. So this might be a red herring, that the fact it now doesn't receive, because it didn't receive before he did the dry joints. But we'll see how many. I'll tell you what, we'll do a control by testing the new part. .2, and the old part 9.2. So that is a red herring, but it wanted changing anyway because we've damaged it. So when I put this back on, it shouldn't be any different, especially when we put it back on channel 20. No, it's stiff as a post. 100 microvolts on the signal generator. It is transmitting all right. So we have to do some fault finding here. Although I'm tempted to get a vibrator out. It's not going to be out of alignment to this extent. So it looks like we've got no effect on that coil or that coil, but we have on that coil and that coil. So chances are we've got a duff transistor. But how does it have transistors? Because the whole point about this version, it's got this chip. You look well if we've got a duff chip. Anyway, that's enough for today. Okay, so the next day, having printed off the circuit diagram, we actually find that the receive is entirely in a chip. So in effect we've got the aerial coming in here in a roundabout way from there. There's a takeoff capacitor from the transmitter, goes to there. There's a protection diode. Now if those protection diodes were short circuit, we would have a very deaf receive. But we have a situation where two coils aren't making any effect, and it was these two coils. I don't have a layout, but it is, you know, all we've got are these scans from instruction books. It could be better. I think it's 104 and 102 to be honest. And that's those two. They are having an effect. So which are those? I think what we need to do is to check we haven't got a short on the two protection diodes. Chances are they're those. One, two. Oh, 108. Anyway, we'll just get the meter on those, and then we'll just check we've got power to the chip. Otherwise, it's going to be the chip that's at fault. Chances are it's had an overloaded front end, or somebody's transmitted up the aerial socket. My late mother had said always do the hardest jobs first, and pick these off the pile, and make sure that you do the one that you've just taken off the top of the pile. Not these are our sets, so try to sort them out so we can flog them on, so they go to a good home. They're not being thrown away. Whatever we do, we lose money, but it means that we're doing a demonstration and it goes to a good home, hopefully. So they're not reading faulty at all. So I'm sure they're the right diodes. If I had a layout, it would help. Right. So where does the power go in to this chip? Just make sure it's getting powered up properly. And I could look at the manufacturer's data, and we could also try and guess it's going in on pin 9. I mean, it's a Kia something or other. So what I'm expecting is we're going to have a scrap chassis, because there's so many of these which we've bought as bare boards for spares, which have been very useful. And I don't know what this is. This is typical of how you end up buying stuff. This isn't one of these. But there's still useful parts. Even there's even a filter there. So they're not as there's a bar graph driver there. So you pay a couple of quid for that, and everybody's had all the best parts of it. No, we've probably got these chips new in stock, but again, we're trying to keep this down to a budget, so keep financial losses to a minimum. What's this? A 104 decent version with a proper channel selector. See, it's a shame, because I bet the fault on that was just something silly. But there you are. There's another couple here before I have to look elsewhere. But they're both. That's a CPT Realistic 2005. Yeah, right. Somebody's tried to convert that into a UK channel set, and of course failed miserably, and of course it would have been illegal to do that. And here we have another one, but it's got the proper channel selector. Got the bar graph driver. Right, well that got us a lot of nowhere, didn't it? We'll just check the voltage. I think is on pin 9. Could download the data sheet. I think we'll just go down this chip for voltages. But I'm sure it's getting its power feed, or it wouldn't work at all, surely. Because it is receiving at 100 microvolts. And if it wasn't working at all, it wouldn't be receiving at all. Now the annoying thing is, of course, these things start up on channel 9 every time. Can't even find the underside. It's there. So is that pin 1 or is that pin 9? There's no power there. Oh, we're in ohms. Half a volt there. Nothing there. Five volts on that pin. And where I'd expect a full rail voltage, it's half a volt. I think we're going to have to download some more information. I have this on file. I say download. Might have to pull it off the computer. I've got a full instruction book. I think it's got a layout. So we'll do that. So I've done a bit of research. Got a layout. These are scanned, first generation scans from a instruction book. But we're still down to can we read the device type. So what I've done, I couldn't read that, and I can't on the computer screen either. So what I've done, I've found a scrap chassis that somebody's kindly donated, rather than one that's here on the floor which I've bought. And I've taken out the IC. Now it may not be one of these sets, but it's going to be something which is the D version. It could be the 805 or whatever. But nevertheless it's this chip, and it's a Kia 7358AP, which is the Kia version of the Toshiba TA7358, which is an FM front end chip. So we can see you've got bandpass filter in, and that's it. It's straight in and it's straight out, and it turns out it's 5 volts on pin 9. So pin 9 we should have 5 volts. So I've taken that out, but only to identify the part number. But if this is faulty, we can of course use that to change. So pin 9 is obviously the opposite end to pin 1. Pin 1 is there, so pin 9 is at that end. So let's see what we've got. One, two, three, 4, 5, 6, 7, 8, 9, which should be there. We've got 1.7 volts. So that's not right. And of course the answer here is the chip dragging it down? Well, look, if we look at our power consumption, it's 170 milliamps. I think could be high for a fairy light set. So I'm tempted to take the chip out, just to take the load off the circuit. So that's what we'll do. Okay, so I took that chip out, and I find out it's a different chip. So it's a Kia 6058 rather than the Toshiba or the Kia version of 7358. Same kind of thing, but it's different. Supply volt's 8 volts. So we better check which pin it's on. It's still on pin 1? No, it was pin 9, wasn't it? Yeah, pin 9 VCC. So it's still the same pin out. So that's the chip in question. Right, well, we'll get this back up and we'll see whether we've got 8 volts rather than the 5 volts we were looking for on pin 9. So whichever end it is, we're not getting anything. I'm going to put the aerial in. We're just going to transmit. Just make sure the set's working apart from the receiver. I'm trying to plug a DNT mic in. How stupid's that? Yep, that's fine. That's transmitting. Now, we didn't have deviation yesterday, very low. Wow. Now we have today. So we've taken the load off the 8-volt rail. Testing 1, 2, testing 1, 2, 3. And we now have transmitted audio. So that does tell us that the voltage rail is being dragged down, whatever that voltage rail is. But we still haven't got, I didn't see 9 volts where I was expecting it. Just in case I'm not getting a proper earth, I'll actually connect it to physical earth. So connect our negative prod to the power supply. Negative. Pin 9. Nothing there. Because that's pin 1. Yep, that's definitely pin 1. That's interesting, you know, take the chip out, we've got audio back on transmit, but we haven't got the voltage reappearing. Let's have a look at the circuit. So, it looks like 102 feeds that. Let's go for that. See 103. Tell you what, if we measure it at the capacitor 108, the electrolytic 108, it looks like 108 anyway. There's 106. Is it 106? It could be 106. You see, this is a difficulty. You know, you can imagine how small this is. This is blown up about 10 times. So, although it's a high quality scan, it's a matter of what you start off with the printing. So 106, the positive end of that, should be at the rail voltage. So 106 is there. So that's going to be that one. We've only got 5 volts there. Just turn it off. Is this a short circuit here? Just turn it off. Is this a short circuit here? 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 Is this a sh can see a short circuit. This isn't introduced by Mr. Chippy either. Mr. Chippy's been working around the VCO here, which has brought back the operation of the synthesizer, and he's brought transmit back. But you know what? I think somebody's probably gone around this for dry joints and they've done a Mr. Blobby. And this could be our fault. So just wait for the smouldering back to warm up. Resolder that. I think, folks, that's got rid of our short circuit. Let's put the meter back on there. Wherever there was. Still 4.6. Here's another short circuit there. And that's definitely a short on that coil. It's probably knocked a resistor out further down the chain. I'm going to look carefully for more short circuits because it looks like Mr. Blobby's been soldering it around there. Right, folks, I've just gone around it for a few more little possible dry joints and things touching, and if we look at pin 9 now, we've got 7.2 volts. So that's 3 little short circuits which have been introduced by some careless soldering. So you know what, we'll put this chip back. Sorry to have accused you, but you can see what I've done. If that was faulty and we had an internal short circuit, and our current consumption has gone down to 166 milliamps, so we're only talking about a 4 milliamp short circuit. If that was short circuit, of course the voltages would be robbed. So we'll put it back in, and hopefully we're going to have full operation. Just going to make sure these pins are something like square. I'll just make sure I can put it in from the wrong side first. Some debris just there. Yep, that goes in fine. I might need the surgical scissors off Mr. Chippy's bench. We'll try it with the pliers. We'll try it with the other pliers. Annoying thing about that meter, I know you can shut that down and here we are, it's gone in. You just don't know when all these events happen. I mean, there's no two ways about it. This set, the phase lock loop wasn't working because of the dry joints in the VCO which Mr. Chippy's dealt with. And then straight away, once I got rid of that little whisker he managed to introduce, we then had transmit. He's probably had no receive for decades. You know, we'll have put 90 minutes into this so far. Let's see what happens now. Right, we better plug the extension speaker in. See where the signal generator is. Because it's not being, the set wasn't working, I couldn't take before figures. But we've got S9 and it's showing S9. So let's go down the signal generator. There's 1 microvolt. So it's now receiving perfectly. It's a bit of a detective exercise there. I didn't visually see those short circuits. There were 3 of them. Right, we'll go through a normal tune-up. So we've done the transmitter. And we'll just go through that with you. Picture-in-picture on. Oh, I've gone through it, haven't I? I don't know if I have. Well, we'll go through it again if we are. I'll tell you what, we'll put it on frequency first. We're going to the frequency counter. So this is low hours. There's no two ways about it. Dry joints. Short circuit on the receiver through no fault of the set zone. Somebody's going to get a low hour set. So right now it's doing 5 watts, which isn't going to help us. In fact, I'll tell you what, we'll put it on low power because I don't want to burn out the transmitter. 2779071, so it's off frequency enough for it to be noticeable, but not illegally off frequency. Perhaps it'll go, perhaps it won't. Yeah, 2779125. So let's go back to full power. Right now it's doing 5 watts on channel 20. I assume the people who turn these up to 5 watts also drive their car with the accelerator to the pedal in the wrong gear. 5.2. .6, and I can hear it groaning as well, which is not good. So do these have a power? Oh, we've got to set them up at full power anyway first. So here's our layout of what we need to do. Transmit, transmit, transmit. There shouldn't be the coil in one of these. So the preset to the left is transmit power. So let's see where that is. Oh yes, it's at full, yes. Right, channel 20, oh, let's put the current consumption down when we get back to channel 20. 1.493. So we need to check, because it's not right, because it's lopsided a bit more than is ideal. So no, that wasn't at peak. That now is. I'm unkeying between because I don't want to burn out the transmitter. They're not capable of running at full whack. Going back to my days at Nottingham Radio, we used to do the Olympic AM VHF high band sets in a lot of taxi firms. Going back to the 80s, a lot of AM schemes, not to be confused with Citizens Band. AM was authorised on VHF high band, and some of the other bands it was the earlier method. And most of these Olympics were 10 watts. I think they were 10 watt radios. You had a 60 watt PA. You had to tune them up like 45 watts, and there was smoke coming out of it. So you soon used to be doing it very quickly. And the boss, John, would say, you're tuning for maximum smoke. We're not going to do that unless it's been fiddled with. That's the one done with the spectrum analyzer. So I think we're at maximum. I'll just go again with that one. Okay. Now we'll turn the power to 4 watts. Just like that. And we'll see what we've got on the other channels. We've got 4 watts on channel 20. We've got 4 watts on channel 40. We've got 3.95 watts on channel 1. So that's pretty well balanced. So go back to, when this is cold, it'll be 4.0, and that will be a full 4. So current consumption is now 1.234. It's not grunting now. So low power, I don't know whether it's a preset on these, I doubt it, is 360 milliwatts. Let's see what it says. No. It's well worked, that, because 360 milliwatts is very close to the 400 it should be. That was really low. It was something like I think it was something like 200. I'll put 200 in. It's balanced up, sorting it out. Let's look at deviation on here. Wow, now I've fiddled with that, so that's nothing I can really say there. So we'll set it for where it should be. Wallow. And we'll see where it is with the test set. Those chips you can spend 14 quid on one of those, So it's best not to change things willy-nilly. I mean, these were a budget set, weren't they? Like £39.99 type set. Now this test set isn't switched on, so we're going to have to wait 20 minutes to take that measurement. So I'll take a break at that point, get myself a coffee. Right, that should be enough time, so let's go. One, it's a little bit high that, so I'll just pop it down. Wallow, wallow. Let's see what the Marconi meter makes of that now. Wallow. Well, it's a little reading a bit low on the Marconi one today. It's saying 2.2 where I've got 2. So I can't see what that was before because I'd altered it. It could have been 3.5, which is what I kind of had. So it's now 2.2 to 2.5 where it should be. So on transmit, this is the power meter supposed to read 1 on low power and a full whack on high power. So I don't need to adjust that, it's exactly right. So the preset for that is there. So the one to the left is transmit power, the one to the right is the meter. Right, we'll go through the receiver now. See, the VCO has never been messed with, and that's brilliant. So we're going to start with the detector with 100 microvolts on the signal generator, put the oscilloscope on, let's look over at the oscilloscope and drop stuff on the floor which will never get picked up. Let's check we've got peak recovered audio. Not quite. I can't say what this was doing before because I've had to fiddle with it to verify what was wrong with the receiver. But I've only messed with those 4 and not that. Let's go over to the oscilloscope. We're on the oscilloscope. Go over to the synod meter. Check we're still on frequency. We are. And let's go for it. So before, with that short circuit, the receiver chip was only getting, was it 0.9 of a volt, and its minimum operating voltage is 1.5, so it's kind of working a bit. At least that was in the right place. That was in the right place. To be honest, that doesn't look right. That does though. Just going to untune this and retune it in case it's in a false spot. it's not doing 12 dB. No, it's not right. We'll have to investigate why it's not right. Okay, so I've changed the ceramic filter. Put one on a scrap realistic CPT set. And we've got better performance, but not good. 104D, D stands for deaf, and it is. So we've got 1 microvolt for 10 dB. It was 2.2 microvolts with the other filter. Oh, I've just checked, because I've just changed the filter, I'll recheck my detector. No, it's no change. Right, if we can get 12 dB, we can. Where is it? Well, the answer is it's 1.2 microvolts, which is about the minimum you could have acceptable. 2.2, 2.5 is where those swish-looking Cobra 29s are, because I think they're as deaf as a post. I think everybody else thinks they're as deaf as a post. And the 20 dB, which it does fine, is 1.75 microvolts. Squelch. Need to adjust that. It is too coarse. At the moment it is, I'll tell you where it is. It is never ever opens. And so it was 2.5 microvolts at its best. Threshold. .5. So that is too coarse. This will receive down to 0.3 of a microvolt, but for 12 dB, because of the noise it has, it's 1.2. So it's not as deaf as you think it is. Well, we'll find out, won't we, around Scratchy Corner. Right, need to adjust this squelch. And let's hope we can. Squelch preset is there. Don't know where we are, to be honest. That's it. Minimum squelch So exactly 100 microvolts, which is what we want. So it's minimum internal squelch with maximum full squelch, if you understand that. So if I put the attenuator on here, if I can find which bit of the floor the remote's gone on. So 3, 10, 30, 100. Squelched. Not coming quite that time. But that's about where we are. Let's look at where sensitivity is on the squelch. So I can put 100 microvolts down now. Set threshold. .5 still. I'll just see whether we can just set the squelch a little bit better. I mean, 1.5 will just do. It's got quite a wide hysteresis. Right, that's threshold really carefully set on the radio. Signal generator back on, parked at 0.3 of a microvolt. It's not doing 1. Right, 1.3. So look at the S meter. Supposed to read S9 on 100 microvolts, which it does, but I just want it to be, I want to see how it is so we can see plus 30. Yeah, it needed to be a bit higher than that. So plus 30 we can bring in with 300 microvolts. That's a bit better. That's it, isn't it? Everything done. Good. So we'll see how that works on a scratchy corner test. Didn't say I knew where the bottom lid was. Oh yes, it's there. It's quite nice condition, to be honest. I wonder when this last worked. Oh, I've got the power lead to do. So I can't be messing about. We'll do that behind the scenes. Right, we'll disconnect the test equipment. Check it's working on its. Now that's another point about these sets. Now I've disconnected the aerial. Oh, we've got a noisy volume control, haven't we? Something else to deal with. I was going to say, sometimes you don't have the squelch opening when you haven't got an aerial connected, and it isn't nice, but it is normal. One on, Roger. Right, I'll do the power lead, clean the controls, and we'll get a scratchy corner test on that one. So, bit of a long-winded repair. So, just to recap, Mr. Chippy did dry joints round the VCO, and unfortunately, little whisker ended up shorting out the 8-volt power rail, so I changed the resistor, even though it was still working. I thought that was probably why the receiver wasn't working, which isn't the case, because there were some short circuits introduced by somebody else looking for dry joints in the past. So there were actually no actual electronic faults, but living up to its D for deafer than normal, it certainly does. And it comes in at 1.2 microvolts, but it does receive down to about 0.3. And the fact these people we can hear there are at Nottingham, probably on burners, but they're nevertheless 35 miles away. So thanks for watching. That'll find its way on eBay at the cost price of the mic and the power lead.